Imagine for a second that you are witnessing the greatest construction boom in human history.
Right.
Massive industrial parks, literally billions of dollars poured into the architecture alone. And everyone, the media, investors, the public, everyone is entirely obsessed with the skyscrapers.
But there's a flaw, a massive structural flaw.
A systemic flaw that no one noticed until it was almost too late. We completely forgot to build the highways between them.
So you end up with a city where the traffic is just so impossibly bad that those beautiful billion-dollar skyscrapers are sitting there basically empty.
Right. The workers can't get in, the goods can't get out.
It's completely paralyzed.
And that structural failure, that exact scenario, is what is happening right now under the surface of the artificial intelligence boom.
It really is. The world is just, completely obsessed with the raw processing power, the GPUs, the AI chips.
The existential crisis is the nervous system. It's how those chips actually communicate. If you look at the fundamental architecture of these trillion-parameter AI models, the processors are starving.
Because the data simply cannot travel fast enough between them. It's the hidden hardware bottleneck of the entire AI revolution.
Which is exactly the uncomfortable truth we are unpacking today. Welcome to another episode of Delta Investments Deep Dive, where we go in depth and unpack our research on specific stocks and discuss the risks.
I'm Sloan.
I'm Marcus. Actually, I always do that. I'm Marcus.
And I'm Sloan.
And today, we are focusing on a fascinating case study. The company is POET Technologies.
We've been going through a really dense stack of sources for this. Q3 2025 and Q4 2024 financial reports, SEC filings, a bunch of press releases, and this incredibly detailed analyst report called The Optical Inflection.
And the mission here, for you listening, is to really pull back the curtain on how this one specific company is trying to solve that data traffic jam. We're looking at their core premise, which is replacing electricity with light to move data.
But we aren't just looking at the theoretical science, right? We are tracking their transition from an R&D incubator to a commercial manufacturing player.
Which is famously the most dangerous phase for any hardware company. So to understand the stakes, we have to start with the physical roadblock the industry is slammed into. In all these filings, they keep referring to the Interconnect Wall. What is the fundamental truth, the actual physics behind this wall?
Well, to understand the Interconnect Wall, you have to look at how data fundamentally moves. For decades, we've relied on copper wires. We use electrons to send information between chips. But as data centers scale up to handle AI, the sheer volume and speed of that data, it's exposed the absolute physical limits of copper.
Because pushing electrons through metal generates friction.
Precisely. It creates resistance. And that resistance manifests as heat and signal loss. When you push massive amounts of data through copper at these incredibly high speeds, the signal degrades so quickly that you have to spend, massive amounts of power just to boost the signal so it reaches its destination.
So we've reached this bizarre tipping point in modern data centers. The energy required just to move the data between the chips actually exceeds the energy required for the chips to process the data.
Exactly. You are literally spending more energy fueling the delivery truck than you are manufacturing the actual product.
That's profoundly inefficient.
It's unsustainable. Look, if you extrapolate the power demands of copper interconnects over the next 5 years of AI growth, you would need dedicated nuclear power plants just to handle the data traffic alone.
Right, which is terrifying. So the obvious scientifically proven solution is photonics. You use lasers.
Yeah, you move data using photons instead of electrons. Light travels infinitely faster. It generates practically no heat, and it uses a fraction of the power.
But reading through these sources, it becomes really clear that traditional photonics has this massive fatal flaw when it comes to manufacturing. They describe it as a packaging problem. Let's unpack that. Why is it so hard to package light?
The industry term is active alignment, and it is, quite frankly, a manufacturing nightmare. In traditional photonics, assembling an optical engine is this artisanal, painstaking process.
Artisanal, like by hand.
Basically, yes, you have these microscopic lasers, modulators, sensors, and lenses. To get the light to travel perfectly from a laser into a waveguide, these components must be manually aligned to sub-micron tolerances.
Which means someone, or I guess a highly specialized, very slow robotic arm, has to hover a microscopic lens over a laser in real time.
Yes, you literally have to power up the laser, fire a beam of light, and then micro-adjust the lens while measuring the signal output until it is perfectly maximized.
Wow.
And when you find that exact spot, you glue it in place with UV epoxy. But as the epoxy cures, it shrinks.
So the glue itself can pull the lens right out of alignment.
Exactly. It takes minutes to assemble a single chip. When AI clusters demand millions of these optical engines, handcrafting them is a catastrophic bottleneck.
Which brings us to the core of POET Technology's solution. They've spent years developing this proprietary platform called the Optical Interposer. The analyst report calls it a motherboard for light. But let's really demystify that for the listener. What is an interposer structurally, and how does it bypass this artisanal assembly line?
So the optical interposer is a dielectric platform. It's built using advanced wafer-level semiconductor manufacturing techniques.
Okay, dielectric meaning what exactly?
It simply means it's a perfect insulator. It does not conduct electricity. This is crucial because it completely eliminates electrical crosstalk. You can lay down high-speed electrical traces right next to optical waveguides, and they don't interfere with each other at all.
And how did that solve the laser alignment problem you mentioned?
Because POET chemically etches the alignment features directly into the interposer at the microscopic level. They create physical indentations. Think of them as perfect little parking spots for the components. This means they completely eliminate the need to turn the lasers on and manually align them. A standard automated pick-and-place machine from the semiconductor industry just drops the components into their designated spots and they align themselves perfectly.
So it takes the slow, really expensive world of optics and forces it into the fast, cheap, high-yield world of semiconductor manufacturing.
Exactly. It's passive alignment.
But look, I have to challenge this. I'm looking at the broader industry, right? And you have the most powerful tech giants on Earth pouring billions of dollars into silicon photonics. They're trying to solve this exact same problem using silicon as the base. What makes their approach fundamentally different from what the trillion-dollar incumbents are doing?
It really comes down to the atomic reality of the materials. Silicon is, without a doubt, the greatest material on Earth for conducting electrical logic. But it is what physicists call an indirect bandgap material.
What does that actually mean in practical terms? Let's break that down.
Think of the atomic structure of silicon like a crowded, bumpy highway. When electrons travel down that highway and drop in energy, they release that energy as a vibration.
Okay.
That vibration creates friction, which creates heat. It does not create light. An indirect bandgap material simply cannot emit a laser natively, period.
So silicon photonics is essentially trying to force everything onto a silicon substrate, even though it's the wrong material for light.
And that requires incredibly complex, expensive, and really inefficient workarounds just to attach an external light source to the silicon chip.
It sounds like, and tell me if this analogy works, it sounds like silicon photonics is trying to build a high-performance sports car, but the engine, the tires, and the seats are all carved out of the exact same block of wood. Just because wood is the material they're historically used to working with.
That is the perfect analogy. And whereas POET is saying, let's just build a universal chassis and we'll buy the best rubber for the tires and the best aluminum for the engine and just snap them all into place.
Which is their hybrid integration model.
Exactly. Because the optical interposer is a universal dielectric platform, they aren't tied to one material. They can use the absolute best material for each specific job. For the lasers, they use indium phosphide.
Because indium phosphide is a direct bandgap material.
Yes. It's like a frictionless track where electrons efficiently convert their energy directly into photons.
And they attach it using flip chip bonding, right? I saw that in the reports.
Yeah, and flip chip bonding is as simple as it sounds. You literally flip the microscopic indium phosphide laser upside down and snap its tiny solder bumps directly onto the pre-etched pads on the interposer.
Wow. No wire bonding, no active alignment. You just bring the best-in-class components together on one passive motherboard.
You've got it.
Okay, so we understand the tech. But having a technological breakthrough in a lab is only half the battle.
What is the untold story behind their balance sheet?
The untold story is survival. The financial filings paint a very stark picture of what crossing the valley of death looks like for a hardware startup.
It's brutal. You look at their Q3 2025 numbers, they posted a net loss of $9.4 million. And historically, their revenue hasn't come from massive product sales. It's come from these small, non-recurring engineering fees.
In that same Q3, their revenue was just $298,000.
Which is terrifying for an investor to see.
You were burning millions of dollars every single quarter to perfect the atomic structure of this interposer. You're paying brilliant engineers, testing materials, while practically nothing is coming in from the market.
The anxiety in that phase has to be immense because the runway is constantly shrinking. But then, right when it looks like the water has run out, they stumble into this massive oasis. Between late 2025 and early 2026, the filings show a profound financial inflection point.
They finally secured the capital to build the city.
In October 2025, they closed a $75 million private placement from a single institutional investor. That was the largest raise in the company's entire history at the time.
And then, literally just a few months later in January 2026, they executed a massive $150 million registered direct offering, pricing those shares at $7.25.
So across those few months, with warrants and other mechanisms, they pulled in $250 million in equity financing. They went from carefully watching their cash burn to sitting on a pro forma cash position of over $300 million.
That is a staggering pivot. But look, having cash doesn't equal having a sustainable business. They have to transition to actual repeatable product sales.
And the Q4 2024 and recent updates show that transition is actually beginning. The filings highlight 2 successive initial production orders from key customers. Those orders are valued at over $5.6 million.
Which, relative to a $1 billion market cap, sounds kind of small.
It is small in pure dollar terms, but psychologically and strategically, it is massive. It represents the start of the revenue ramp for 2026. It proves to the market that the optical interposer works outside the laboratory and that Tier 1 customers are actually willing to pay for it in volume.
So if you look at their playbook for the next 5 years, what is the ultimate end game here? How do they scale this globally?
To achieve global scale, they have to navigate the macro environment. And today, where you build your infrastructure matters more than ever.
Right, because the supply chain for advanced semiconductors is arguably the most geopolitically sensitive ecosystem on the planet.
Absolutely. And POET recognized this early. They executed a very deliberate fab-light strategy. They made the strategic decision to mitigate geopolitical risks by transitioning their manufacturing completely out of China.
Yeah, I noticed in the reports, they mentioned the dissolution of their joint venture with Sinan IC, which was known as Super Photonic CMN. They literally packed up their production equipment and moved their assembly and test operations to Penang, Malaysia.
And Malaysia has quietly become this massive neutral hub for semiconductor back-end manufacturing. POET formed strategic partnerships with 2 major players there, Globetronics and NationGate.
How does that breakdown work?
They installed specialized wafer-level processing equipment at Globetronics inside a 10,000 square foot clean room. That gives them the capacity to produce 1 million optical engines annually.
Wow.
Yeah. And meanwhile, the NationGate facility is dedicated specifically to producing their Starlight and Blazar light source products, which they just showcased at the OFC conference in LA in March 2026.
But wait, I have to push back here. They've moved all this complex manufacturing to Malaysia to avoid the China tech war. That sounds brilliant on paper for mitigating geopolitical risk.
Yeah.
But aren't they just trading political risk for a massive quality control risk? Well, handing off submicron laser assembly to a third-party manufacturer like Globetronics usually tanks your yield rates. If you outsource artisanal manufacturing, you generally get a mess.
Marcus, sorry, I know we're just talking here, but if this were traditional photonics, that pushback would be 100% correct. Asking a third-party manufacturer to manually align lasers with microscopic tweezers would result in terrible yield rates. It would be a quality control nightmare.
Right.
But you have to remember the core value proposition of the optical interposer.
The passive alignment. The pre-etched parking spots we talked about.
Exactly. POET's technology inherently simplifies the assembly. Because the alignment features are physically built into the wafer itself, the bonding process is fully automated. When POET hands this off to Globetronics, they aren't asking them to align lasers.
Globetronics simply uses their standard, highly automated semiconductor machines.
The pick-and-place machine drops the components into place. The interposer does the hard work. That makes outsourcing the manufacturing exponentially less risky and far more scalable than anyone relying on active alignment.
Okay, that makes sense. And if we look at their product arsenal, how are they upgrading the speed to meet the demands of these AI data centers?
Well, the industry is currently in this massive upgrade cycle, moving from 400G to 800G optical transceivers.
And to give you, the listener, a sense of that scale, if you look at the back of your standard internet router at home, you're likely dealing with a 1 gigabit connection. POET's Infinity line of pluggable engines handles 800 gigabits per second. You are multiplying a heavy home network's entire capacity by 800 and squeezing it into a chip the size of your fingernail.
It's incredible. And even that isn't fast enough for the future of AI. Data centers are already architecting their next-generation clusters for 1.6 terabits per second. To meet that, POET developed their Teralight series,
which just won an elite score of 4.5 at the Lightwave Innovations Reviews.
Right, which is a massive validation from the industry's technical judges. And they recognize they can't build all of this alone. They are acting as a strategic force multiplier by partnering with massive established players.
Yeah, you see these partnerships peppered all throughout the filings. In March 2026, they announced a collaboration with Lithium, a massive optoelectronics provider. They partnered with Semtech for 1.6T receivers. They have collaborations with Sievers Semiconductors and even NTT Innovative Devices.
But if we are really looking at the frontier of what is possible, the partnership that serves as their true moonshot was announced in November 2025 with Quantum Computing Inc., or QCI.
Right, the 3.2 terabit per second optical engines, targeted for the second half of 2026.
Exactly.
I was digging into this QCI partnership, and I kept seeing this acronym TFLN, Thin Film Lithium Niobate. From what I gather, it acts as a much faster shutter for the laser, but I'm struggling to understand why traditional materials simply fail at these 3.2T speeds. What is the physical limitation they're hitting there?
It comes down to modulation. A laser produces a steady beam of light, right? A modulator is the microscopic shutter that chops that light into pulses, the digital ones and zeros of computer code. To achieve 3.2 terabits per second, you have to push 400 gigabits through a single lane of light. If you use standard silicon modulators at that speed, they require too much voltage to open and close the shutter fast enough.
And that high voltage generates heat, and the signal degrades into noise.
Precisely. The shutter basically starts melting or stuttering because it's moving too fast. But TFLN has a unique physical property. Its refractive index changes almost instantly when a tiny electrical voltage is applied.
So it requires a fraction of the power to switch the shutter on and off.
Exactly, meaning it generates almost no heat, even at 400 gigabits per lane. It is the perfect material for ultra-high speeds. But historically, TFLN has been notoriously fragile and really difficult to integrate at scale.
Which is why the QCI partnership makes so much sense. QCI has the proprietary expertise to manufacture the TFLN modulators, and POET provides the optical interposer to passively integrate those fragile modulators with the lasers and electronics without breaking them.
They are combining the fastest shutter in the world with the most scalable assembly platform in the world. They are aiming to double the speeds of the fastest networking devices currently on the market.
That is profound. When you synthesize all of this for the listener, we are looking at a company sitting at a highly asymmetric inflection point. They hover around a $1.14 billion market cap. They have over $300 million sitting in the bank to fund their commercial scale-up. And their optical interposer platform has the mechanical potential to become the fundamental architectural standard for the 1.6T and 3.2T data center era.
And this matters to every single person listening, because the continued evolution of artificial intelligence, the speed of cloud computing, and the future of the internet fundamentally rely on solving the physical heat and speed limits of copper wiring. We have to move data with light.
And we have to do it at an industrial automated scale. If we can't, the AI revolution simply stalls out.
Exactly.
We desperately need the highways to match the skyscrapers. Which leaves us with a final thought for you to ponder long after this deep dive ends. We are currently replacing the electronic nervous system of artificial intelligence with light, simply to reduce heat and mimic the sheer efficiency of the human brain. But if light is just the stepping stone to true efficiency, how long until we abandon silicon entirely and move to biological computing? If photons are the present, what comes after the light?
That is a fascinating question about where hardware eventually intersects with biology. It really changes how you view the whole trajectory of tech.
It really does. Something to think about. Well, we hope you enjoyed this deep dive, and thanks for listening. Please follow us and subscribe on your favorite platforms. Don't forget to check out our Substack, Delta Investments. Until next time.
This analysis is based on publicly available information and does not constitute financial advice. Always conduct your own research before making investment decisions. By listening to this podcast, you agree that you are in charge of your own decisions and risks, and that you are solely responsible for any investment decisions you make.